press the bell icon on the YouTube app and never miss another update.
Hi students, under number system, in the previous class we have learnt how to locate root 2 on the number line. Let us continue with the topic, and today we shall learn how to locate root 3 on the number line. So, to locate root 3 on the number line. So, for this what we have to do is, first you draw the number line. This 0 is in the middle, this is 1, 2 and so on. This is -1, -2 and so on. Now this is 0, 1. Let us mark 0 as point O, and where the graduation 1 is there, let us mark this as A. So now at A, draw a perpendicular and mark point B such that OB is also equal to 1 unit. You know that it is 0, this is 1, therefore OA is also 1 unit. So this we have learnt yesterday while marking root 2. So same procedure, of course, join OB. Join OB. Now, whatever I have done so far, I will put it in the sentences. Draw the number line. So, number line is drawn. Mark at 0 and 1 graduations as O and A respectively. So therefore OA will be equal to 1. So this is length is 1 unit. Now at A, draw a perpendicular at point A. Draw a perpendicular to x-axis. So OB is the perpendicular to x-axis. Mark point B. How to mark point B? The length should be equal to 1 again, such that AB equals 1. Now we know that this is a perpendicular, therefore this is 90 degree. So now we have a triangle OAB. It is a right angle triangle. In triangle OAB, angle OAB equals 90 degree and OA equals and OA equals OA and OB and OA and AB equals AB equals 1 unit. Both are 1 unit. So by Pythagoras theorem, we have hypotenuse whole square, OB square equals OA square plus AB square equals 1 square plus 1 square, because OA is 1, AB is also 1. So 1 square plus 1 square is 1 plus 1, so that is equal to 2. So OB square equals 2. So therefore take square root on both sides, you will get OB equals root 2. OB equals root 2. Since OB is root 2, we want to locate root 2 on the number line. So this distance is root 2, we can mark here, it is root 2. So now at what we have to do is, with using compass with O as center and OB as radius, draw an arc to cut the x-axis at say some point. Let us say we have to cut it like this and we will get the point P, and OP distance is same as OB distance, so OP will be equal to root 2. So OP will be equal to root 2. So this is how we can locate root 2 point on the number line. So now with, I will write here, with O as center, with O as center, using compass, of course, using compass with O as center, you write like this. Using compass, you write first, using compass with O as center and OB as radius, and OB as radius. Draw an arc to cut x-axis at point P. X-axis at point P. Since OB is radius, OB equals OP, and this is equal to root 2. Point P represents root 2 on number line. So here our aim is to mark root 3. So we have to continue procedure little further and mark root 3. So for this I will erase this to continue my writing. See, we have marked root 2 on the number line. So, what we need is root 3. So, therefore, what we have to do is, we have to continue construction little more. Observe here, at point B, draw a perpendicular to OB. Let this point be called as C, let us say. Here, this angle is 90 degree and BC must be equal to 1 unit. Now, join OC. Join OC. Now, in triangle OBC, OB is root 2, BC is 1 unit, and OC we have to calculate. So, now to continue further, at point B, draw a line perpendicular to OB. Draw a line perpendicular to OB. This is the perpendicular line, and mark point C on it. Mark point C on it. How to mark point C? Such that BC must be equal to 1 unit. Such that BC distance is equal to 1. Now again we use Pythagoras theorem here. From figure, triangle, we have triangle OBC. In triangle OBC, angle OBC equals 90 degree. We have this data. OBC is 90 degree. OB distance we have calculated is root 2, and BC we have taken it as 1 unit. So now again by Pythagoras theorem we have OC square is equal to OB square plus BC square. OC is the hypotenuse, OB square plus BC square. So OC square equals OB is root 2 whole square. OB value is root 2. So therefore I am putting root 2 whole square plus BC is 1 unit, that is 1 square. Root 2 whole square is 2 and root 2 whole square, you know that root 2 whole square equals root 2, 2 to the power half whole square we write. This is 2 to the power 1 by 2 into 2, 2 and 2 get cancels, we will get 2. So therefore this is 2 plus 1, that is equal to 3. So OC square is equal to 3. OC will be equal to root 3. So we have found out the distance OC is root 3. This distance represents root 3, but we want root 3 on the number line. So therefore what we have to do is, with OC as the radius and O as the center, using a compass, again you draw a curve, draw an arc to cut the number line at point say Q. If you draw a arc like this, it will cut at point Q, let us say, at point Q. So with using compass, you write using compass with OS center and OC as radius. OC is nothing but root 3 distance. OC as radius. Draw an arc to cut x-axis at point Q. Since OC equals OQ, so OC equals OQ equals root 3. So therefore point Q represents root 3 on number line. So this is how we can represent the irrational numbers on the number line. So in the similar fashion, if you continue with this, again you have to take a perpendicular here. You can find out the root 4, that is 2 is readily available, root 4 is 2. For root 5, you can continue the process in a similar manner, and this line is known as the square root spiral, we say. Root 5 also you can calculate in the similar manner. So we have learned how to locate root 2 on the number line, root 3 on the number line. You can continue this process and even you can find out the location of root 5 on the number line. So we will continue with the topic. We shall continue with the topics real numbers and their decimal expansion. So next topic, real numbers and their decimal expansions. So we know that real number consists of both rational and irrational. rational and irrational. So now the real numbers and their decimal expansion. Under this, first we will study the rational numbers and their decimal expansion, and in the next topic we will study the decimal expansion of irrational numbers. So rational numbers, first I will take up decimal expansion of rational numbers. First we have to understand what is a decimal number and what is a decimal expansion of that number. Suppose if I write 1 by 2, we know this number is in the form of p by q. So therefore, p is an integer, q is an integer here, and it is not equal to 0. Therefore, it is a rational number. We call this as a rational form of this number. Now, if I divide 1 by 2, we will get, this is not divisible, therefore I will put 0 here, and after putting a decimal, we will take 0, 5, 2 5s are 10, so we will get the 0 remainder. So therefore, this is a simple division. You all know that half is nothing but 0.5. This is known as rational form. Rational form of this number. Whereas this 0.5 is known as decimal form of this number. Whenever a number is given in the rational form, we can convert this into by dividing into decimal form, and when it is given in the decimal form, we can convert this into rational form. The 1 by 2 is known as the rational form because it is in the form of p by q, and this is in the form of 0.5. So we call it as a decimal form. So now the decimal expansions of rational numbers, how do they behave, that we are going to study here. For that, let us consider the following numbers and their decimal expansion. So I advise the students to take down the notes while looking at the video. That will help you. So now, first one under this, say 8 divided by 5. 8 divided by 5. Now, if you divide 8 by 5, you can see, you know the division process. 5 ones are 5. So 3 is the remainder. Now 3 is not divisible by 5. So what we do is we will put a decimal here, 0 here, 5 6 are 30. So we will get 0 remainder. 0 remainder. Now we say the division process is terminated. So, they are complete. So, whenever we get 0 remainder, the division process terminates. It is over. So, 0 remainder. We got a 0 remainder. And the division process terminated. And we got 1.6 as the answer. The decimal expansion here, it will not continue. Decimal expansion is terminated, 1.6 terminated decimal expansion, you can say decimal expansion. We cannot expand it further, expansion, decimal expansion terminated. So, let us take another example, 1 by 4 let us say. So therefore 8 divided by 5 is, we got 1.6. 1.6. Let us take second one, 1 by 4. You all know this is 0.25. If you do the actual division process, this is 1, this is 4. 1 is not divisible by 4. So therefore we put 0 and 0 here. 4 2s are 8. 2 is the remainder. Now again we will put a 0 here, 4 5s are 20 and we got 0 remainder. So, division process, we got the 0 remainder as in the previous case, and the decimal expansion here, it terminates, we cannot continue further. Decimal expansion terminates. Decimal expansion terminates. Let us take two more examples. Third one, 1 by 3 let us say. 1 by 3. So here you observe what happens if we divide 1 by 3. See, 1 is not divisible, therefore we put 0 and a decimal. It becomes 10. 3 3s are 9. Remainder is 1. Again, we will take a 0 here. 3 3s are 9. We will get remainder 1. Again we will get 0 here, 3 here, 9. Again 1 remainder. You observe here, the remainder never become 0. When the remainder never becomes 0, the decimal expansion, the quotient will never stop. So, it will continue to grow 0.33333 like this. So, we say it is continuing like this. The decimal expansion is not terminating. Decimal expansion not terminating. And one more thing you have to observe here. Again we are getting 33333. When the remainder is not, we are getting 0. The decimal expansion is not terminating, and also the digits are repeating. So we say it is non-terminating repeating. Non-terminating repeating. When it is 0, it is decimal expansion is terminated. It is non-terminated division process, and we are getting repeating quotient. So, you know, this is the quotient and this is the remainder. Remainder here 1, 1, 1. Remainder is repeating. Remainder is repeating, and we are getting non-terminating repeating. Non-terminating decimal expansion, and it is repeating. It is repeating. And I will take up a final example, fourth one, say 1 by 7. You observe here carefully. 1 by 7, if you divide, 7 by 1, if you divide, you have to divide 1 by 7. This is 1, here we will take 7. So, here the answer is 0.333, and it will continue, and we represent it as 0.3. Above this we will write a bar. So, that means this bar indicates the digit 3, decimal 0.3 is repeating. 0.333 continuation is represented 0.3 bar. So, here if you divide 1 by 7, it is not divisible. So, therefore, we commence with a decimal point, it becomes 10. So, 1s are, it is 7. What is the remainder? Remainder is 10 minus 7 is 3. So, therefore, it becomes 30. So, 4s are 28. So, 2 is the remainder, it becomes 20. So, 2s are 14. This is interesting, you must practice it. So, here 6 is the remainder, it becomes 60. 8, 7 8s are 56. So, 4 is the remainder, 40. So, therefore, we will get 5s are 7 5s are 35. So, we will get 5 is the remainder, it becomes 50. So, now 7 7s are 49. 49. So, 1 is the remainder again. You can see we started from 1, again we got 3, we got 2, we got 6, we got 4, we got 5, and again we got 1. 50 minus 49 is 1. 1 means 10. The same process will continue. So, and we will get 1 4 2 8 5 7 1 4 2 8 5 7 1 4 2 8 5 7 and so on. It will never end. The quotient will repeat like this: 1 4 2 8 5 7 1 4 2 8 5 7. Likewise, it will repeat. Therefore, we say 1 by 7 equals 0.142857. We put it like this. Instead of writing a long number in the decimal fashion, we write it like this: 1 by 7 is 0.142857. Above it we will draw a bar. This represents these numbers are repeating. So, in this case also we are not getting a zero remainder, and the quotient is non-terminating and repeating. So, of course, here only one decimal was repeating. Here there are 6 decimals: 142857, 142857, 142857. It repeats indefinitely, and the division will never end. So, this is the behavior of the decimal expansion of rational numbers. Broadly, there are two categories. So, one, whenever we get a zero remainder, we call it as a decimal expansion terminates. For any rational number, we can say there are only two categories. For any rational number, the decimal expansion terminates, or whenever it is non-terminating, it is recurring, we say. That means it is repeating. We will not get, say, here one number and here another set of numbers, here another set of numbers. It is not like this. So, it is numbers are repeating in case of the decimal expansion of rational numbers. So, with this we will state it in the standard form. With this we can write like this. Observe this carefully. The decimal expansion of by observing the above examples, we can come to conclusion that, so this is very important, the decimal expansion of a rational number, the decimal expansion of a rational number is, there are two types, either it is terminating or it is non-terminating repeating. So, we say it is recurring, is either terminating or non-terminating repeating. Non-terminating, we say recurring. Recurring and repeating are same meaning. Non-terminating, repeating. Suppose if it is not terminating, it will not terminate. Whenever it not terminates, the digits will recur. That means digits will repeat. So, this is. Moreover, we can say, moreover, a number whose decimal expansion terminates or non-terminating repeating, non-terminating repeating is a rational number. Now, you understand the second sentence. Suppose if I write say 0.2. So you all know that it is a terminated decimal expansion. When it is a terminated one, we can definitely say it is a rational number and it can be put it in the form of P by Q. So to put this in the form of P by Q, what can you do? 0.2. To put it in the form of P by Q, we will simply multiply and divide it by 10. We will get 0.2 into 10 is 2, 2 divided by 10. So this is of the form P by Q. 2 by 10 and 0.2 are not the same. And non-terminating repeating. Suppose if you have a 0.3 bar, let us say, this can also be represented in the form of P by Q that we are going to study in detail. Therefore, it is also a rational number. Now, on this topic, we shall take one or two examples. Express some examples on this. Express the following. In their rational form. See, the numbers are given in the decimal form. We are supposed to express them in the rational form. See, first one 5.34. So, you know how to convert this into P by Q form. 5.34 can be, so 5.34, so answer you have to write like this, answer 5.34 you take as it is and 34. See, after the decimal there are two digits, 34. After the decimal, two digits are there. Therefore, you multiply by 100 and divide by 100. The value will not change. The numerator becomes 534 divided by 100. So, this is in this, it is of the form P by Q, where P is an integer, 534 is an integer, 100 is an integer. So, therefore, P by Q and Q is not equal to 0. So, therefore, the 5.34 is the decimal form and its rational form is 534 divided by 100. So, similarly, second one 0.381. So, in this case, what you have to do is, so answer. So, here after decimal there are three digits. So, therefore, 0.381 you multiply it by 1000 and divide by 1000. So, you will get 381 divided by 1000. So, again it is of the form P by Q, is of the form P by Q. One condition is satisfied. P is integer, Q is integer, and Q is not equal to 0. So therefore, what is the conclusion? Therefore, 0.381 is decimal form. And 381 divided by 100,000 is its rational form. I think you understood these things. This is all today. Thank you all.